This is problem 4-7. We're doing 2D moments now. So for this one, we need to find the moments due to force F1, F2, and F3 about point A. So let's see, I made a mistake here. It's all about point A. So to find these, we could either do a scalar method or a vector method. Let's start with the scalar method. So the moment about F1 or of F1 about A, that would equal that perpendicular distance times the force. And then we're going to make it positive moment is out of the board. So the perpendicular distance to that force is just going to be that 2 meters. And then we just want that perpendicular component of that force. So that would be times 250 cosine of 30 degrees. So we're just picking up of this one here, that perpendicular component. So F1 of y. And that's newtons there. So you get Newton meters. And then we need to decide if it's positive or negative. We can use our right hand rule. So go from point A, which is drawn in the drawing, point A to that force, curl your fingers down in the direction of the force, and my thumb's pointing into the board. So that makes it a negative moment. And it's negative because I said that coming out of the board or towards me was positive with this little symbol here. So we just need to do that. So I'm going to calculate that. So I get 433 Newton meters. So negative 433 Newton meters. So that means the moment is 433 Newton meters, and it's negative, so it's going into the board, which would mean that it's clockwise. So we could write it like that. So that was for F1. So we also need to find the one for, I'll see where I made the mistake earlier. So F2 and F3. F2 and F3. So we could do the moment of F2 or due to F2 similarly. So we could use that vector method. We can also use that scalar method. We can also use the vector method, and maybe we'll do that just to get some practice with it. With this one, it's probably a lot easier just to use the scalar method, but I just want to make sure y'all see that. So for the scalar method, so the moment of F2 about A equals R from A to, we'll call that point B. So the position vector from A to B crossed with that F2. So the position vector from A to B is just going to be 5 meters in the I direction. So we're making this X and up is Y. So position vector of A to B, which also could be written as position vector of B with respect to A. But that equals 5I meters. Now the force of 2 is going to equal, so we can just do sine and cosine here, right? So 300 times cosine of 60 is going to give us that I component, and then minus 300 sine of 60 degrees is going to give us the J component. So now we have R, or the position vector, and the force in Cartesian coordinates. So now we can do it one of two ways, and I'll show you both ways just so you know it. So so one way we could do it is just take each of the components. So I cross I doesn't create a moment. I cross J does create a moment. And if we use that rainbow method, so I, J, K, So I cross j would give us a positive k. So I is that 5 from that position vector, and j is that negative 300 sine of 60 degrees k. So I cross j is positive k. The I cross I is just 0, so that would give us that let's see, calculate it quickly. We get 1299, so 1,299 Newton meters in the K direction. And so if we rewrite that, we could put it in kilonewtons per meter, so 1.3 kilonewton meters, and it's in that negative direction, so into the board, which would be clockwise. So that's one way of doing it. The other way, if we wanted to use the determinants, which this will become really helpful whenever we, let's see, let me write the moment, F2 about A. We could also use the determinant method. And with that, we just set up I, J, K. For the I, we have 5, it's R cross F. So R is the second row. So 5A, 0J, 0K. And then F is that 300 cosine of I, or cosine of 60. J is negative 300 sine of 60. And then K is 0. And so for that one, we have I times 0 minus 0 times that. So that's just 0 minus J of 5 times 0, or minus 0 times that, which is 0 again. And then plus K times, or K times 5 times negative 300 sine of 60 degrees. And then that's minus, so K of this times that. Let me do that in different color. So K of that times that minus that times that, and that's 0 times something, so 0. And so that gives us that 5 times negative 300 sine of 60 K, so that'll be negative 1,299 Newton meters K. And that's the same as what we found above, right? So if we want to simplify it, we can just say it's 1.3 kilonewton meters in the clockwise direction. So I just showed those two to you because there are other ways, alternative ways you can solve it. The last way you can solve it is just using the vector method like we did before. And with that, you would just do the perpendicular, or the distance times the perpendicular component of the force, or the perpendicular distance times the force. And the way they drew this one, I would just do the 5 meters is that perpendicular distance, or that distance, and then that perpendicular component of the force would just be 300 times sine of 60. So that'd be 5 times 300 sine of 60 would give you the same thing. So these are like overly complicating it a little bit, but you can always use these to check, right? Let's do the last one now. So let's see, we've got, this was one of them. That was one, and then the last one is the moment due to the F3. So the moment due to F3 about A. And for this one, we can do the, or you can do whatever method you want to do. But what I would probably do is just sort of figure it out. So I would take the distance. So I would look at, let's see, if we do this 5 meters, and then we take that vertical component of that F3 to figure out part of the moment. And then the other one, we can take this distance times that horizontal component of the force, and that'll give us the moment. So with that, we'll get that, yeah, we get 5 meters times F3 is at 500 newtons. And then we just want that vertical component, so 4 over 5 times 4 over 5. And so we're basically just breaking down that force into 2 components. So this will be F3 in the x direction, F3 in the y direction. And so that's, for this one, we want this distance, or this distance from here to here, times that F3. And that's going to give us, if we do the right-hand rule, that's going to give us a negative moment. And then we can do this distance, it's a different color. So this distance times that F3 of x, and that's going to give us 4 meters. And that F3 of x is 500 newtons times 3 over 5. And then we'll do the right-hand rule again. So from A to that force, put your fingers in the direction of the force. My thumb's pointed towards me, so that's positive. And so we get that. And that gives us, what is it? Use a calculator. So that gives us negative 2,000 Newton meters plus 1,200 Newton meters. And so that gives us 800 or negative 800 Newton meters. And since it's, so if we want to rewrite that, so M of F3 about A equals 800 Newton meters, and that'll be in the clockwise direction. And that's the last one.